Once upon a time, our planet was a tropical paradise. Warm waters near what we now call Arkhangelsk were home to crocodiles, and Antarctica and Australia were still a single landmass. Vast stretches of land were inhabited by colossal creatures, the dinosaurs. They ruled the Earth, and then, they vanished. Scientists refer to this event as the Cretaceous-Paleogene extinction. In popular culture, it is simply known as the dinosaur extinction. But what exactly happened back then? Around 66 million years ago, right between the Cretaceous period and the Paleogene, a fifth of all living creatures on Earth disappeared in an astonishingly short time. This included about 16% of marine animals and 18% of land-dwelling species. That might not sound too terrifying. Just 200 million years prior, Earth had endured the Permian-Triassic extinction, an event that wiped out around 60% of all species on the planet. Yet, even an 18% loss of land species and 16% of marine life was enough to severely impact every ecosystem then in existence. Suffice it to say, not a single medium or large-sized species remained on land. For several million years afterward, land-dwelling life longer than a meter simply didn't exist. Soon enough, by geological standards, of course, ecosystems did recover. But the dinosaurs were gone. Of course, one could argue that dinosaurs still walk the earth today. Birds, for instance, are direct evolutionary descendants of Archaeopteryx, the first dinosaur to master flight. Crocodiles are also close relatives of dinosaurs. However, the giant tyrannosaurs, the small and agile predatory velociraptors, the immense herbivorous Diplodocus and Brachiosaurus, and the marine plesiosaurs, all of them vanished forever. So, how did we even figure out that dinosaurs had disappeared? It all began in the late 18th century, with an idea so audacious it was almost unthinkable. Georges Cuvier proposed that species could, in fact, go extinct. Before him, the prevailing belief was that the planet, with all its animals and plants, was immutable, existing in precisely the form God had created it. Cuvier's groundbreaking insight was essentially this: hold on a minute, what about the Great Flood? Perhaps things were different before then? Interestingly, Cuvier himself didn't believe in evolution. He interpreted Earth's history as a series of divine creations, each followed by various catastrophes, also brought about by divine will. This worldview became outdated even during Cuvier's lifetime, and with each new discovery, the year 1859 loomed closer, the year Charles Darwin's revolutionary work, On the Origin of Species, was published. Darwin's theory managed to connect a vast number of fossil remains into a unified picture, helping paleontologists understand how life on Earth had evolved. However, Cuvier's ideas didn't simply vanish after Darwin. For the next 100 years, two schools of thought debated vigorously. Eventually, Darwin's ideas prevailed. Throughout the latter half of the 19th century and the first half of the 20th, it became common wisdom that dinosaurs had gradually faded from the evolutionary race. It was even considered uncouth to speak of their extinction as a sudden, cataclysmic event. Over those 100 years, plenty of theories emerged to explain this supposed evolutionary pressure. One such theory suggested that flowering plants, which gradually released alkaloids, slowly poisoned the dinosaurs. Other versions were more complex. For example, some proposed that dinosaurs died out because mammals were preying on their eggs. Overall, there were as many theories as there were experts studying the topic. Surprisingly, when it came to dinosaurs, Cuvier ultimately proved to be correct. Everything changed with Iridium-77. This shift only happened in the 1970s. In 1973, the so-called Black Queen hypothesis was formulated. Its core idea is that for a species to survive, it must continuously evolve alongside the ecosystem it inhabits, or perish. By then, it was understood that in stable ecosystems, roughly 5% of all species are, on average, in the process of going extinct. It seems straightforward enough. No new dinosaurs emerged, the old ones died out, case closed. But in 1977, American scientist Luis Alvarez discovered a metal called iridium at the boundary layer between Mesozoic and Cenozoic rock formations. This metal, exceedingly rare on Earth's surface, was found in an incredible concentration within the deposits from these two geological epochs, hundreds of times more than in any other known rock formation. Such high levels of iridium had only ever been detected in meteorites before. A year later, in 1978, a Mexican oil company working in the eastern part of the country, on the Yucatan Peninsula, stumbled upon a massive geological anomaly. This structure, over 150 kilometers in diameter, covered the entire peninsula and extended far out into the sea. Crucially, the timing of this anomaly's formation matched the geological period of that inexplicable iridium surplus. As often happens, the scientific community spent several more years resisting these new findings and concepts. But soon, the paleontological tide turned. Disparate data from various parts of the world, the US, the USSR, Australia, and Africa, began converging into a single, cohesive picture of a colossal catastrophe. Luis Alvarez's hypothesis was now receiving significant confirmation. Yes, an asteroid had indeed struck Earth, leaving behind the Chicxulub crater, the very one mentioned earlier on the Yucatan. It's important to note, however, that the asteroid wasn't the only factor at play. Roughly 72 million years ago, a dramatic drop in sea levels began, nearly 200 meters. Marine ecosystems found themselves in a precarious state. Simultaneously, the climate was undergoing significant changes. The planet's average temperature at the time hovered around 25 degrees Celsius, much higher than today's levels, yet between 68 and 66 million years ago, severe fluctuations were observed. On several occasions, Earth's temperature plummeted by 10 degrees Celsius, only to rebound almost immediately to its previous level. A full 500,000 years before the Cretaceous-Paleogene boundary, evidence of intense volcanic activity emerges. Half of the Indian subcontinent transformed into a vast zone of magmatism, with enormous lava flows bursting through cracks in the Earth's crust and spreading across millions of square kilometers. Concurrently, ashen gases were spewed into the atmosphere, triggering a volcanic winter on Earth. Not only did it get cold, but acidic rain also fell, and the ocean's acidity shifted dramatically. While we can't speak of mass extinction yet, ecosystems suffered a very serious blow. Not a fatal one, mind you, a slow recovery could very well have begun after this crisis. That is, if it hadn't been for the asteroid that slammed into Earth 66 million years ago. This asteroid measured over 10 kilometers in diameter. Billions of tons of Earth's crust vaporized in a fraction of a second, turning into ash and soot that coated the entire planet in a thick layer. Tsunamis crashed onto continental coastlines. Falling debris superheated the atmosphere, raising temperatures by hundreds of degrees and transforming the air into a searing oven for several minutes. The seismic shockwave from the impact triggered volcanoes across the globe, and in mere minutes, the planet transformed from a tropical paradise into a hellscape of superheated air, sulfuric acid rain, rampant fires, and perpetual twilight, all because the sun was obscured by a dense shroud of smoke. It was a horrifying catastrophe of truly biblical proportions, quite literally an apocalypse. Yet, the impact wouldn't have been so devastating if not for the marine issues that had begun even earlier. The foundation of marine ecosystems was phytoplankton. These microscopic creatures, though small in overall biomass, are the very bedrock of all life in the ocean. Phytoplankton feed zooplankton, which in turn nourish fish, krill, jellyfish, mollusks, and countless other creatures. These then become food for predators like ammonites, with their giant shells, and plesiosaurs, with their 10-meter necks. The climate catastrophe led to the demise of microplankton, and by the time the asteroid arrived, there was practically none left. The productivity of marine ecosystems plummeted to near zero, severing the food chain. Among marine inhabitants, only some cephalopods survived, along with organisms partially connected to land, such as amphibians, turtles, and crocodiles. If mosasaurs and plesiosaurs might have still clung to existence somewhere at the moment of the asteroid impact, the subsequent acidification of the ocean and the complete annihilation of microorganisms delivered the final blow. On land, the situation was different. While marine creatures were nearly wiped out by climate problems, land animals, conversely, were stimulated. In response to sharp temperature shifts, complex communities with highly specialized species began to emerge. Towards the end of the Cretaceous period, flowering plants appeared, entering into a complex symbiosis with the insects of that era. Thanks to the emergence of grasses and turf, grasslands appeared for the first time. During the warm parts of the day, the land belonged to cold-blooded giant reptiles, while at night, it was the time for numerous small mammals. And while mammals occupied the lowest rung of the food chain, dinosaurs commanded the middle and upper levels. At the moment of the asteroid impact, this proved to be their undoing. The marine catastrophe wiped out most of the phytoplankton, while the terrestrial disaster primarily devastated vegetation. For the first few years after the asteroid hit, daytime on Earth was as dark as a moonless night. Understandably, this led to the death of most plants, annihilating the food source for all herbivorous creatures. Specialized herbivorous dinosaurs, such as the giant sauropods, were the first to go extinct. Following the demise of herbivores, naturally, large predators vanished first, then medium-sized ones. Smaller theropods lasted a bit longer. They had every chance of surviving this extinction event, were it not for the fierce competition. Mammals and birds gave them no quarter in the post-apocalyptic evolutionary struggle. Theropods had neither wings to flee nor warm blood to withstand the cold. Birds and mammals survived, though they didn't fare much better than the dinosaurs, with 90% of them going extinct. Several decades after the asteroid impact, the Earth's surface was utterly transformed. The planet became much colder, but it gradually began to recover. Vegetation was the first to revive, with surviving plant seeds beginning to sprout after years of darkness and cold. The surviving organisms started to spread. After the death of nearly all life, there was an abundance of unoccupied ecological niches. Among those who found success, three groups stand out. First, there were the ray-finned fish. Once a small and not particularly successful group of fish, we know what became of them today. Most of the fish we're familiar with have bones. Second, of course, were the mammals. They were once small, nocturnal creatures living in the shadow of dinosaurs. After the dinosaurs' extinction, they found themselves at the pinnacle of the biological world. There was an explosive diversification, an increase in size, and the emergence of specialized species, all happening very rapidly, within just 100,000 years after the asteroid. Essentially, mammals are us. Third, oddly enough, were the surviving dinosaurs. Despite the demise of marine and terrestrial species, one branch of dinosaurs, birds, gained an immense advantage in this new world. The undeniable benefit of flight and their relatively small size allowed birds not only to survive but also to become one of the most numerous animal groups. Today, there are over 10,000 species of them. A million years after the mass extinction, Earth was once again fully populated at all levels. Life was bustling and evolving anew. But it was an entirely different world, with different conditions, a different climate, different life forms, and, of course, without those gigantic reptiles that had, so recently, been the kings of all creatures on our planet. In short, the Cretaceous-Paleogene extinction was a culmination of several complex and sequential processes. Not only the asteroid impact but also significant climate change played a role. Despite all this, life persevered and continued, just as it had after other great extinctions. And while dinosaurs are unlikely to ever again dominate Earth, their evolutionary descendants live among us still.